Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. So this is about me. I am a computer science gate faculty having more than 5 plus of teaching experience, mentored more than 50,000 students, taught in different coaching institute all over India. Okay, it's like the Gate Academy, even qualified multiple times Gate. And even I have given the coaching in many government colleges as well as in many private colleges. Like in SRM Chennai, I have given coaching. CAT Bhubaneswar, I have given. BC Bhagalpur, Jorhat College of Engineering, Guwahati University, Dibrugarh University, Government College of Engineering and Technology, Jammu, Ramgarh Engineering College. Okay, these are the colleges where I have went and I have given the coaching. Now we are going to see randomized Quicksort. Now, the first question will come in our mind. Now, why randomized quicksort? So, see, randomization is a general tool. It's a technique. If you are some algorithm, if you are having some algorithm which is having bad worst case, but good best case, but good average case time complexity, then randomization is a technique so that you can use this tool to improve the time complexity of an algorithm. Okay, you can use these techniques to improve the time complexity of an algorithm. See, randomization is a tool. It's a tool to improve the time complexity of an algorithm if it is having a bad worst case. It is having a bad worst case, but it is having a good average case. Then you can use the technique that is called as randomization to improve the time complexity of an algorithm. Okay. So it is a very good technique. So whenever you will see that its worst case is bad, so in real time, we are not going to use quicksort. We are going to use randomized quicksort. In every time in real world, you will see that we are using randomized quicksort because worst case scenario of quicksort is big of n square. We want to improve the time complexity of that. We don't want to go in worst case. So what we do, we use randomization, the technique to improve the time complexity. Okay. So we are going to see randomized quicksort. So randomization is a programming languages. They are using randomized quicksort, right? Because in real world, in practice, if you will see, the scientists have found out that randomized quicksort performance is far better than the quicksort. Okay, so randomization, randomization is a general tool. It's a general tool. Is a general tool. See, it is not going to be easy to understand this one. Okay, so because that's why I need your concentration here. It is little bit tough. Okay, means the code will be easy, but to analyze the time complexity of this, it's going to be little bit tough. So I need your concentration. So randomization is a general tool. It's a general tool to improve algorithm. So to improve algorithms with with bad worst case, but good average case, average average case average case time complexity, but good average case time complexity. Okay, so it is a general tool to improve the algorithm with bad worst case but good average case time complexity. That is very important. Okay, it's very important. So we are going to assume here that all the elements are distinct. Some assumption we have to find. So second is assume all element are assume all elements are assume all elements are distinct. You assume that all elements are distinct, means different. Then use partition. So partition, here we are not going to use the simple partition. So partition around a random. So in this method, we are going to do partition around a random element. So you can choose any element. You can choose any element as the pivot element. Okay, so I have told you that we are having a four type of quicksort. One is if you will choose the first element as pivot. Another is if you choose the last element as pivot. Another is if you choose the median as the pivot. And the last one that you will choose the random element as the pivot. That is random. In the first lecture of quicksort, I have told you that in four ways we can call the quicksort. So this is the randomized quicksort where partition around a random element. Around a random element. You can take any element as the pivot element. That is the pivot is the pivot element, that is the pivot is chosen randomly. That is the pivot is chosen randomly from the given set of from the given set of elements. From the given set of element, you can choose the any element as the pivot element. Okay, so because of that, consequently you will have, see, consequently all these splits, consequently because of that, consequently all splits like 1 is to n minus 1, 1 this kind of partition, 2 is to n minus 2, like same 3 is to n minus 3 till n minus 1 is to 1 are equally likely, means all are having a possibilities of partition. So this way the partition can happen, all are equally likely with probability, all are equally likely with probability 1 by n. Okay, so all are having equal probability, means this partition can happen or this partition, like uniformly this can happen, this can happen, this can happen, any one can happen. Okay, please let me know whether it is clear or not. So you assume all elements are distinct. So partition around a random element, that is the pivot is chosen randomly from the given set of elements. So you can choose any element as pivot, any element as pivot element. So consequently, all these splits like 1 is to n minus 1, 2 is to n minus 2, 3 is to n minus 3, n minus 1 is to 1 are equally likely with the probability 1 is to n. So all the partition can happen with the probability 1 is to n. So any of, so if I ask you what is the probability of that, all are having a equal probability. So any partition can happen. Okay. Now see how we will write the code here. So here partition will be randomized partition. Randomized partition will happen. So if A is the array, P is the start symbol, R is the last symbol, then we will assign I equal to, see, this is the pseudocode. In this way we write the pseudocode. So we are assigning at I the value, the random is going to one function. See, in some programming language there are some function which is going to give you the some random element between, if you write P and R. So it is going to, see, it will generate, it generate it generate a random element, it generate a random element, generate a random element, you can say that random number between, it generate a random number between, it generate a random number between P and Q, between P and R, including 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 PNR, including PNR. Okay. So this is a function. You will see in different programming language there will be some function which is going to generate some random number between P and Q, including PNR. So I is going to have some index. I is going to have some index which is going to, is it fine? So I is going to have some index between P and R. Okay. Now you will exchange, math means you are going to do swap with the last element A of R with A of I, A of I. Okay, A of I. Now you are going to exchange with the last element with the index that you got. See, you have chosen some index as the any element between P and R. Now you are choosing that element as pivot element. See, now you are choosing. So you are swapping that index element with the last. Now you will call the partition element, and partition. So that simple partition is going to call an APR, and that is going to return. You are going to return this. You are going to return this. See, please let me know whether it is clear or not. So you are calling some function random, which is going to generate some random number between P and Q, including P and R. Then you are choosing any element as the index that random is. Now you are going to exchange the last element with that element, Now you are going to call the partition on that chosen element, because you have swapped the last element with the one that you have chosen and you are calling the partition. Am I clear to all of you? Then now I will show you. So partition is that function that we have shown you in Quicksort. Now after that we are going to call, now I will show you the randomized quicksort. So this is the randomized partition you have seen. Now we will see randomized quicksort. So your randomized quicksort, randomized quicksort is going to call randomized partition APR. So it will check if P is smaller than, if P is smaller than R, then you are going to call, if P is smaller than R, if P is smaller than R, then Q is going to your randomized, the index that is quicksort is that partition. So you are going to call here randomized partition on APR, okay, and then you are going to call randomized quicksort, randomized quicksort from A, starting index P and last is Q minus 1. Then again randomized quicksort A, okay, then Q plus 1 till same way. So in another half, first half you are calling then, and next half you are calling. This is the randomized quicksort, okay. So now we will see the time complexity of that. Now we will try to find the time complexity. What is going to be time complexity of this randomized time complexity? Okay. So first point, let T of n, let T of n, let T of n be the expected. See, here I need your concentration, okay. Let T of n be the ex expected 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 number of comparisons, expected number of comparison needed to quicksort, needed to quicksort in element, in element, in elements, in elements, okay, in elements. Now you know that since each split, since each split, each split, since each split, since each split occurs, since each split occurs with probability, with probability 1 by n, each split is having the probability 1 by n, okay. So n is the total number of n, every is having equally likely, like 1 by n. In quicksort, you know that in quicksort every number, in quicksort every number require at least n minus 1 comparison, n minus 1 comparison, because we are going to do n minus 1 comparison with the pivot element, okay. Comparison at least you require n minus 1, because in the n minus 1 number, because the n minus 1 number, because the n minus 1 number have to be compared with the pivot element. So n minus 1 number require, because n minus 1 number have to be, so I will go to the previous slide, just to wait, have to be compared, have to be compared with pivot element, pivot, okay. N minus 1 comparison is required, okay. N minus 1 comparison. So right, this slide you write. So here I am assuming let T of n be the expected number of comparison needed to quicksort n element, to means if you are having n element and you are calling quicksort n element, then the time is required T of n. Now since each split occurs with the probability 1 by n, so each split is going to occur with the probability 1 by n. Now in quicksort every number require at least n minus 1 comparison. So in quicksort every numbers require at least n minus 1 comparison, because the n minus 1 number need to have to get compare with the pivot element. Okay, so if you're done with that, then you please let me know. So in Quicksort, you know that because of the partition, you will get the time complexity as big of an as there we are saying that. But the number of comparison here, it should be your n minus 1. It should be your n minus 1. Now we will assume that some ith element is chosen as the pivot element. Let the pivot let the pivot is ith smallest element. I am choosing as the random ith smallest element. Let the pivot is ith smallest element. Okay. Then then on one side how many, please comment, then on one side how many element you will get, then on one side we get, then on one side we will get, tell me, I minus 1 I minus 1 I minus 1 element I minus 1 element I minus 1 element in left side you are going to get I minus 1 because I the smallest element you have chosen, so I minus 1 element you will get on one side. Okay, then on one side, yeah, correct. So in one side you are going to get I minus 1 element in left side, and in right side, and n minus I element on element on right side. So on left side you are going to get I minus 1 element, and in right side you are going to get n minus I. Then we have to do again randomized quicksort on I minus 1 element and n minus 1 element. We have to do now randomized quicksort randomized quicksort on I minus 1 elements and and n minus 1 n minus I n minus I. So it will take t of I minus 1 plus t of n minus I as time complexity as time. So the difference will going to take this much. So in one side you are going to get I minus 1 element, another side you are going to get n minus 1 element. So there the time complexity on one side it is going to be t of I minus 1, another side will be t of n minus 1, t of n minus 1. Okay, so total time is going to your, so therefore total time is going to your t of I minus 1 plus t of n minus I plus n minus 1, or with probability 1 by, probability is having 1 by n. Its probability is having 1 by n. Probability is having 1 by n. So t of I minus 1 plus t of n minus 1 plus n minus 1. Because n minus 1, why? For the partition. For the partition, this is because at least you have to compare with n minus 1 n. Now, with the probability is having 1 minus 1 by n. So all the combination, all the possible combinations you have to consider, because here you have chosen the ith smallest element. Next time can be I plus 1 smallest element, then I minus 1 smallest element. Right now you have to consider all the cases. So you have to find the expectation. You have to find the expectation. That is going to your 1 by n summation of I equal to 1 to n, I equal to 1 to n, t of I minus 1 plus t of n minus I plus n minus 1. You are considering now all the cases now I'm considering all the cases from I equal to 1 to n, because you are having total n numbers you are having. So can be one smallest element, can be second smallest element, can be third smallest element, can be fourth smallest element, because it's a randomized quicksort, any element you can choose. So everyone is having a probability 1 by n. This is the expectation. This is the expectation. This is going to give you the time complexity of the randomized quicksort. So see, I have told you that it's not going to be that much easy, because it is going to be used in your real time. Okay, this is going to be the expectation. So scientists had did a very good work to find the time complexity. Now we'll find the time complexity of this. It look very fantastic. Okay, it is very awesome algorithm. So 1 by n sigma I equal to 1 to n, because for every possibilities I am going to take with into 1 by n, all the probability. I am checking all the probabilities. Okay, like this first element can happen, second element can happen, third element, fourth element, five elements. I am taking all the possible combinations. So that is the expectation. Now you see here I equal to 1 to n. I will see individually. Okay, I will see individually. Now see this one, sigma I equal to, see, in any place if you have any doubt, feel free to ask me. I can repeat any content. Okay, so t of I minus 1, how it is going to run? It is going to first t will be have, first t will be, so it's with summation from I equal to 1 to n. First t will be 0, because when 1 minus 1, then I will be 2, 2 minus 1 is t of 1, then t of 2, then t of 3, then it will go till n, it will go till l, so it will be t of n minus 1. It is going like this. Okay, it is going like this. Now another is sum I equal to 1 to n, and here it is having t of n minus I, n minus I. So when your I is your 1, you are going to get t of n minus 1, plus when I is your 2, then t of n minus 2, then t of n minus 3, then t of n minus 4. Like this it will keep on going, and at last you will get I equal as n, I equal as n, that is going to t of 0. So see here, you are getting t of 0. Similarly, you will get t of 1. Similarly, you will get t of 2. See all this term, t of 0, t of 1, t of 2, t of 3 till t of n. It is here, it is running from t of 0, t of 1 till t of n minus 1. Here it is running from t of n minus 1, t of n minus 2, t of n minus 3 till t of 0. Okay. So every term is, if you sum these two, every term is getting repeated twice. T of 0 is getting repeated twice, t of 1 twice, t of 2 twice, t of 3 twice, t of n minus twice. So you can write that, you can write sigma I equal to n t of I minus 1. This quantity varies, this quantity, see, it's very interesting to solve this one. Okay, this quantity varies from t of 0 to t of n minus 1, t of 0 to t of n minus 1, and j equal to 1 to n, that is t of n minus j. This quantity vary from t of n minus 1. This quantity this quantity varies from t of n minus 1 to t of 0, to t of 0. So every term, every term, term from t of 0 to t of n minus 1 appears appears twice. Okay, so every term is appearing twice. So we write it as, so how we will write, I will show you in the next slide. If you're done, then please comment. So you can write as 1 by n sigma I equal to 1 to n minus 1. It will go to n minus 1 t of I, and that is going to be twice, always twice. So constant I am taking outside, 2 I am taking outside. See, 2 I am taking outside, because always two times it is going to be I equal to 1 to n minus 1, and I'm constant I am, and then and another term, see the remaining one, this one, these two you have seen, there, these two you have seen. Now this is, so you will multiply this with this. Okay, 1 by n sigma I equal to 1 to n t of n minus 1 by n, 1 by n sigma I equal to 1 to n n minus c. Okay, now if you see here, this term, if you see, it is going to be, you are going to do a summation of n minus 1 till n times, n minus 1 plus n minus 1 plus n minus 1 plus n minus 1 till n times I equal to 1 to n times. So it is going to be your n into n minus 1. It is going to your n into, so this is going to be as it is. So you can write as a rough here. Okay, as a rough here. So I equal to 1 to n minus 1 t of I, and that is going to your 1 by n. It is going to your give n into n minus 1. This is going to your give n into n minus 1, because you are going to add n minus 1 n number of times, now you are going to do cancel this two. You are going to get n minus 1 only. You are going to get n minus 1. So you got t of n I equal to 0 to n minus 1 t of I plus n minus 1 plus n plus n minus 1. Now you see here. Now you see. Now what is going to be t of 0 and t of 1? When if you are having no element, then you are going to get t of 0 as 0. Note that t of 0 is having 0. T of 1 is having only one element. No need to sort. 0. 0 element, no need to sort. 1 element, no need to sort. Now we have find that t of n is this. Now we need to solve this recurrence. Till now I hope that everything is clear. Okay. So t of n is equal to, in any place if you're having doubt, you can ask me. Okay. T of n is going to be 2 by n sigma I equal to 0 to n minus 1 t of I plus n minus 1 plus n minus 1. Okay. Now you will find t of n minus. Now similarly we will find t of n minus 1. T of n minus 1. See, t of n is 2 by n, then summation I equal to 0 to n minus 1, I equal to 0 to n minus 1, then t of I. So it's running, if your sum, if you are doing n, then 2 by n, so here it's n minus, so it will be 2 by n minus 1, and here I equal to 0 to, here it was n minus 1, because when it was having n, then it was n minus 1, here it is n minus 1, so it will be n minus 2. Summation t of 1 plus, it is 1 less, so it will be n minus n minus, okay, n minus 2. Is it clear? Now I will take minus 2 tn minus 1 minus n plus 2. I have taken these things here, then 2 n minus 1 summation I equal to 0 to n minus 2 t of I, n minus 2 t of I. Okay. Now in this I will multiply. Okay, so if you have written this, then please let me know. So now I'm going to multiply this. So you call this as equation 1. Okay, we need to solve this equation. We need to know 2n summation of I equal to 0 to n minus 1 t of I. Now to solve this, I'm first finding t of n minus 1. Okay, so this thing I taken in left hand side, minus n plus 2. Now I'm going to multiply both side, by n minus 1, n minus 1. So you got here in left hand side t n minus 1 minus n plus 2 as, n minus 1 into n. Okay, and here you are having left hand side, you are having 2. So first write n into n minus, first write. So both side you are going to multiply this. So you can multiply in both side with some constant. I am multiplying with some number n minus 1 into n. Okay, now why I am doing that, you will get now. So in right hand side you are having 2 of n minus 1, then summation I equal to 0 to n minus 2 t of I equal to 0 to n minus 2 t of. So now see, this will get cancelled, n minus 1 will get cancelled. It will be 2 of n summation I equal to 0 to n minus 2 is t of I, which is equivalent to t of n minus 1 minus 2 plus 2 n minus 1 by 2. Now see why I found this. This is equation 2. In equation 1, it was in the form 2 by n I equal to 0 to n minus 1 till n minus 1 it is going to t of I. Okay. So that's why I tried to find 2 of n in this form. 2 of n I equal to 0 to summation n minus 2 t of I. So from 1, so it is going till n minus 1. It is going to till n minus 2. Okay, so you can write from equation 1. You can write equation 1 as t of n 2 of n I equal to 0 to n minus 2 t of I, and the remaining it will go here, it is going to I equal to 0 to n minus 2. So for n minus 1 also it should go. For n minus 1, so it will be t of n minus 1. So plus plus n minus 1. See, I have written in two part. So t of n was, you are having 2 of n summation of I equal to 0 to n minus 1 t of I plus n minus 1. It was having like this. Okay. So I have written here till n minus 2, and n minus 1 I have substituted n by 2. Then in place of I have substituted as n minus 1. See, till n minus 2 I have written in the form of summation, and in place of I have written as n minus 1 plus n minus 1. Please let me know whether it is clear or not. See, this type of questions you will definitely get in IIT. I can guarantee, because these are the ways, the standard way. You will love the way the work is happening. You are getting intact with your real time, in how in real time these things are working. Now in place of this 2 of n I equal to 0 to n minus 2, you have executed t of 1. So in place of that you can write what you got in equation 2. In equation 2 you have got this. So n minus 1. See, in any place, if you are anyone having any doubt, you can ask me. N minus 1 into n, you are getting t of n minus 1 minus 2 plus 2 plus 2 by n t of n minus 1 t of n minus 1 plus n minus 1. Now see. So we got now t of n in terms of t of n minus 1. Now we get t of n in terms of, so this should be minus, this is n, this is n, this is n. You can write from equation 2, you got this from equation 2. So in equation 2 you have written this as n minus 1 by n t of n minus 1 minus n plus 2 t of n t of, so it is in the multiplication, then plus n minus 1 plus. Now we are going to solve this. After solving this we will get the time complexity. See, now we will solve this. See, now how we are going to solve this. So you will write, it is going to be your n minus 1 in t of n minus 1, t of n minus 1, or what you can do, you can see here in the previous slide. You see here it is having t of n minus 1, here it is having. So it will be better if we'll write individually, if we'll write. So it will be better if we'll expand. Okay, so that it will be easy for to understand. N minus 1 by n, it's going to your t of n minus 1, then minus is going to your n minus 1 n into n, then plus 2 n minus 1 into n. Here you are going to get 2 of n t of n minus 1 plus n minus 1. See what I have did, I have just expand the bracket. So in the bracket it was having n minus 1 n, then t n minus 1, n minus 1 n into t of n minus 1, then n minus 1 by n into this is minus, that's why here you are getting minus, then plus 2 into, see, because it is having 2 into, now remaining I have written as it is. Now see, this will get cancelled. Now you are getting minus n minus 1 here, and here plus. So these two will get cancelled out. Okay, these two will get cancelled out. Now you are having here t n minus 1 and n as common. You can take tn minus 1 as a common from these two. Tn minus 1 as a common. Tn minus 1 as a common. Here you are getting n minus 1 as n, and here you are getting 2n, and here you are getting 2n minus 1 by n. Okay, this is a very beautiful recurrence relation. So tn minus 1, you are going to get n as LCM will be n. So it will be n plus 1 by n, because 2 plus 1, 2 plus minus 1 is going to 1, and plus 2 n minus 1. This we have solved. This we got after solving the recurrence. So we got, so you can say that, so we got T of n is equal to n plus 1 by n plus 1 by n, T of n minus 1 plus 2 n minus 1. Now we have even solved. Now after solving we are getting, see, n plus 1 by n, T of n minus 1. So T of n you got as a term of T of n minus 1. Now 2 of n minus 1 by n. 2 of n minus 1 by n. Now you need to, you know that this is going to, see, now to solve this again we have to use something. So here if I'll ask you that which is greater, 2 is greater or 2n minus 1 by n is greater. If you'll use n equal to 10, you are getting 2, you are comparing 2 with this, you are getting to 2 into 9 by 10. 9 by 10 is 0.9. If you do the multiplication you are going to get 1.8. You are going to get 1.8, means this term is smaller than 2. This term is smaller than 2 because you are multiplying 2 with some fraction. N minus 1 by n is going to some fraction like 1 by 2. If n is your 2, you are going to get 1 by 2. N minus 1 by 2 n, so it is going to be 1 by 2. It is going to get 0.5. 0.5 into 2, you are going to get what, you are going to get 1. Okay. So in this way this is smaller than 2. This is smaller than 2. So just to solve this recurrence I will use that in this place it is having a 2. It is having a 2. Just to solve this recurrence I will assume that it is having a 2. It is having a 2. So it is smaller than, because I will substitute in place of, see, just to solve this I am using it is smaller than plus 2. Is smaller than plus 2. Okay. Now I will substitute this T of n minus 1 like this. If T of n is this, then T of n minus, you are writing T of n as this. Now you will write T of n minus, expand. N plus 1 by 2 you have got. Now if you will write n minus 1, so if it is T of n then n plus 1. So it will be n minus 1 plus 1 by 2, then T of n minus 2, n minus 2, then plus 2 and this plus 2 for this plus 2 for this, and this you have written this T of n minus 1 in terms of T of n minus 2. So you will write it in this way, n minus 1 plus 1 by 2, then T of n minus 2 plus 2. Okay. See, this way I have learned in IIT. Okay, this way I have learned in IIT. One professor was there, that professor has solved this. Okay, so it is a very good way to solve. Like you will cancel out, so n plus 1 by 2, here you are going to get n by 2. uh 1 minute. So, sorry, it should be n. Here I have written by mistake n. It is n. So it is n, na? It is n. So here you will write it is n. So n should be n minus 1. So here it will be n plus 1 by n. It should be n. Here also it should be. So this is a common mistake we do. Okay, print like this. In writing I have just missed, in place of n I have written as 2, because it's n plus 1 by n plus 1 by n. It should be, so T of n minus 1 will be n minus 1 plus 1 n minus 1. So it will be n minus 1. Now T of n minus 2 plus 2, you are going to get plus 2. Now you can cancel out this 2. You can cancel out this 2. Now you are going to get smaller n plus 1 in denominator, n plus, then T of n minus 2, T of n minus 2, then here you are going to get 2 times 2 times n plus 1 by n plus n plus 2. 2 times n plus 1 by, because here you are not doing cancel anything. It is n plus 1 by n. In this term it is get cancel, and this term will get cancel, but this term it is going to 2 into n plus 1. See, hope it is clear to all of you. It is going to be little bigger, but it is little bit lengthy, I can say that. Okay, so n plus 1 by n minus 1. Now again break this, so it will be, so it is going to your n minus 2 plus 1 by n minus 2, T of n minus 3 plus 2, and remaining I will write 2 n plus 1 by 2, n, sorry, it should be n plus 2. So this will get cancel out, n plus 1 थोड़ा बड़ा है, n minus 1, then here you are going to get n minus 1, n minus 2, t of n minus 3 plus 2 plus 2. So it is n. Say recurrence relation is not easy. It's not that easy that it's look. Okay, recurrence is not that easy that it's look. Now if when you will get expand, this will get cancel out, so you will get now n plus 1 by n minus 2 t of n minus 3. Now you are going to get n plus 1 by n minus 2 t of n minus 3, n minus 3, t of n minus 3 plus 2 n plus 1 plus 2 n plus 1 by n minus 1. Remaining will be as it is, plus 2 n plus 1 by n plus 2. Okay, so now you can take here n plus 1, n minus 2, t of n minus 3. Now you can take common, plus 2 n plus 1. You are getting 1 by n minus 1 plus 1 by n, like this, plus 2. Now similarly you will do, if you will expand t of n minus 3, if you can similarly expand t of n minus 3. So again this thing will get cancelled out. See, you can take n plus 1, it's going to be n minus 2. Now we are trying to find the pattern. What is the pattern here? So it will be n minus 3 plus 1 t of, sorry, not t of, n only. It will be n minus 3. It will be, since it is smaller, we will at last we will place the big O. Then it will get reduced by 1, then plus 2, and rest will be as it is 2 and plus 1. See, if you are getting any place getting confused, please let me know. Don't get demotivated. Okay, so this is one of the recurrence which is little bit lengthy. So if any place, if you are facing difficulties, you can ask me. Okay, now if you solve this, it is going to be n minus 2 by n minus 3. So n minus 2, n minus 2 will get cancel out. So you are going to get n plus 1, then n minus 2, then n minus 2, then n minus 2. Okay, n plus 1 by n minus 2. So sorry, n minus 3 will be, it will be, because n, okay, let it be n minus 2, then n minus 3. I'm solving this. Okay, then t of n minus 4. Now we are going to get the answer. We are now closer to the answer. Now n minus 4 plus 2 plus 2 n plus 1 as common, which is going to be 1 of n plus 1 of n minus 1 plus 2. So yeah, correct. Now these two will get cancelled out. These two will get cancelled out. You are going to get n plus 1, n minus 3, t of n minus 4, then plus 2 of n plus 1. So these two will get cancelled out. When you will do the multiplication with these, n minus 2, n minus 2 will get cancelled out, and 2 of n plus 1 into n minus 1 will be there. Into n minus 1, n minus 2 will be there. Now 2 of n plus 1. Now see, you are getting close to the answer. You are getting close to, you are getting the, what is the pattern here? What is the pattern here? Now see, n plus 1 by n minus 3, you are getting t of n minus 4, then 2 of n, again you will take common t 2 n minus n plus 1. Again take in between these two, 2 n plus 1 as common. You are getting now n plus 1, n plus 1 as n plus 1, and here it is having n minus 3, n minus 3. You are getting n minus 3 at below, n minus 3. Now you are taking here t of n minus 4. You are getting common here 2 n plus 1. See, you are between these two, you are taking common as 2 n plus 1, 2 n plus 1. You are going to get 1 by n, 1 by n minus 1, and 1 by n minus 2. Now 1 by n minus 2, 1 by n. See, this is going in terms of harmonic equation. 1 by n plus 1 by n minus 1 plus 1 by n minus 2 and plus 2. Plus 2 we are having, carry, plus 2 we are always having. Okay, So we are carrying it. Okay. Now see, means it is reducing in such a way that it is going to always here it is going to be n plus 1, and if it is having here n minus 3, then here it will be t of n minus 4. 1 1, so n minus 3, so it will keep on going like n minus n minus n minus 1, like this it will go. So minus minus will get cancelled and you are going to get 1 here. So it will see, if it is n minus 3, like if I'll take your n is your 4, then n minus 3 is your 1. If you 4, I will take n equal to 4, so you are getting 1 and here you are getting 0. Here you are getting 0. Okay. So if you are getting here 1, so here you will get 0. Here you will get 0. Okay, like this it is going. 1 less, 1 less. Okay. If it is having n minus 3, then 1 less, n minus 4. So if it is having 1, then it will be here 0. Okay. Like this, and here it will be 2 of n plus 1, and it will go like 1 by n, 1 by n minus 1, 1 by n minus 2, like this it will keep on going till, see, it is having plus 2. If it is having n minus 4, then plus 2. So it will be have 0, then plus 2 till it will go plus 1 by 2 plus 2. Please let me know whether it is clear or not. If it is having n minus 4, then it is having till plus 2 it is having. See, if you'll see in the beginning, in the previous one, if it is having n minus 4 we have seen. Now see, when it is having n minus 3, it is having plus 2 is your n minus 1. When it is having, n minus 1, when it is having n minus 1, see, when it is having n1, where it is having n minus 1, it is having it is having n minus 1 here. N minus 3 we have seen. Okay. When it is having n minus 3, you getting this. Okay. Plus 2 it is there. Plus 2. So you are getting till plus 2. You will get here plus 2. So you know that t of 0 is 0 only. T of 0 is 0 only. So you are going to get n plus 1. Says, are you getting or not? 1 into 0, you are going to get 0, and you are going to say you got the answer. 2 n plus 1, 1 by n plus 1 by n minus 1 plus 1 by n minus 2 till 1 by 2 plus 2. See, please let me know whether it is clear or not. Everyone please comment whether it is clear or not. Everyone please comment whether it is clear or not. So you are going to get here 0. This term so is smaller than 0 plus 2 n plus 1, 1 by n plus 1 by n minus 1 plus 1 by n minus 2. Similarly, till you are getting 1 by n plus 2. And you know that 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, it is your harmonic equation. It is your harmonic equation till 1 by n minus 1 plus 1 by n. It is your harmonic equation. I have shown you this. Harmonic series, you can say that harmonic series, which is equal to log n, which is equal to log n, is equal to log n. Okay. So you are going to get here log n till this 1 plus, see, only here it is 1 by 2, only 1 is not there, only 1 is not there. Okay. So it is 1 by 2, 1 by 2. So only here 1 is not there, only here 1 is not there. So it will be 2 of n plus 1 log n minus 1 plus 1, because only in this sum 1 is not there, 1 is not there. Okay. So if you'll see that asymptotic wise it is going to your, now since it is a smaller, you can say that b of n log n, b of n. So that's why we say that randomized quicksort is going to have time complexity as n log n. Randomized quicksort is going to have the time complexity. Okay. Now see, I'm going to give you one recap of that. I'm going to give you the recap of that. So you have seen that till this, I think that it is clear. T of where I have started. Yeah. Till this, I think it is clear. Anyone? So please comment. If you are having doubt, please comment. If you are having doubt, then please comment. Hope till this it is clear. So t of n is going to 2 of 2 by n, I equal to 0 to n minus 1, t of 1 plus n minus 1. So t of 0 is 0 and t of 1 is 0, because when it is having 0 element or 1 element, no further, no partition or no quicksort is required. Okay. So now in terms of t of n is 2 by n, I equal to 0 to n minus 1, it is going t of I plus n minus 1. So it is going to I equal to 0 to n minus 1. Okay, t of I. So when it is having n, then 2 of n. When I am finding n minus 1, then 2 of n minus 1, I equal to 0 to n minus 2. It should go to n minus 2, because 1 less. If n, then 1 less. So if n minus 1, then 1 less. So t of I and 1 less plus, then 1 less plus n minus 2. Now what I am doing, I am taking this on left hand side minus 2, so it will become minus n, and minus 2 was there, so plus 2, and 2 n minus 1 summation of I equal to 0 to n minus 2. This is n minus 2 t of I. See why I am doing this, because to find the equation of that 2 of n, 2 by n. Now to find 2 by n, I am doing multiply. I am multiplying in both sides n minus 1 by n, so that this will get cancelled out and I will get n 2 by n. Okay, this I will get, because I need to solve this. To solve this equation, I am multiplying both side by see here, multiply both side by n minus 1 into n. So I multiplied both side by n minus into n, so this will get cancelled out, and it will be see n minus 1 I have written and multiply, so it's going to be 2 by n, and I equal to 0 to n minus 2, you got I. Okay, that you got, and here it will be this. Okay, now I will solve this. So in place of 2, see 2n I equal to 0 to n minus 2 I have got, but here it is still n minus 2, till n minus 2. So what I have written, I have written this equation, this t of n 2 by n I equal to 0 to n minus 1 t of 1 plus in two ways. Till n minus 2 I have written n by 2 I equal to 0 to n minus 2, and n minus 1 I have written separately. So 2 by n t of summation n minus 1 plus this I have written separately. Okay. Now in place of this, I have substituted from the equation 2 what we got, n minus 1 t of n minus 1 minus 2 plus 2, and plus 2 t of n minus 1 plus. Now I have expand, I have opened the bracket. So n minus 1 by n t of n minus 1 you will get. Now this n and this n will be cancelled, and you will get minus n minus 1. So you will get here minus n minus 1, here it's plus n minus 1, you will get cancel out, and here it will be 2 n minus 1 by n, here it will be 2 n minus 1 by n. Okay, so if you will see n minus 1 t n minus 1 minus n minus 1 into n plus 2 n minus 1, and rest I have written as it is, and rest I have written, see 2n t n minus 1, 2n tn minus 1 plus n minus 1. So this get cancel out because of this, and you got minus here, you got minus here, because of this minus and because of this plus, these two get cancel out, these two get cancel out. And now you are taking t of n minus 1, t of n minus 1 as common, t of n minus 1 as common between these two. So you have taken common t of n minus, so you are getting here n minus 1 by n minus 1 by n plus 2 by n plus 2 by n. Okay, and this I have written this 2 n minus 1, and you are now you do the summation, n will be as a LCM. So if you do, n will be as a LCM, n minus 1 plus 2, it is going to be n plus 1 by n, n plus 1 by n. So this, if you solve this, you will get n plus 1 by n t of n. So you have written in the form of, you got t of n plus, now you got this recurrence, we got this in terms of, now we got t of n in terms of t of n minus 1. T of n is equal to n plus 1 by n, t of n minus 1 plus 2 n minus 1 by n plus 2 n minus 1. Okay, see, it was having 2 n minus 1 by n. Okay, you got. Now you know that n minus 2 into n minus 1 by n is smaller than 2. So in place of this, I am writing as 2 just to solve our equation. Just to solve our equation, I am writing as 2. Okay, so that's why it is now smaller. So t of n is smaller, t of n is smaller to this. Okay, t of n is smaller. So it will be n plus 1 by n. Now in place of tn minus 1, you can write as n plus 1 by n. So n minus 1 plus 1 by n. N is your this. Now t of n minus 2, 1 get reduced, 1 get reduced plus 2, like this. So this will get cancelled out. You will get n by n minus 1, t of n minus 2 plus 2. So when you will open the bracket, this will get cancelled. This will get cancelled. You will get n plus 1 by n minus 1 t of n minus 2, and when you will multiply with 2 with this, you will get 2 n plus 1 by n. You will get 2 n plus 1 by n plus 2. Again you are substituting, you are replacing the value of t n minus 2. So here n minus 2 plus 1, then n minus 2, then t n minus 1 get reduced plus 2. Again you have, again you will get cancel out this. Again you cancel, so you are getting t n minus 2 like this will get cancelled out, this 2 will get cancelled out. See, n plus 1 by n by 2, n plus 1 by n by 2, t of n minus 3, then this will get into it 2 n plus 1 by n minus 2. Now here you have taken common as 2 n plus 1, you have taken the common, you got 1 by n minus 1, 1 by n plus 2, plus 2 is the remaining. Now again you will see it is going n, then 1 by n minus 1, then 1 by n minus c. You got here, see, in the beginning you got here n, when it is having n minus 1 you got n, because you add, okay. So you, where it was, so I was here, so you got n minus, here you got, so here you got when it is having n minus 3, you add 2 plus 2, you got here n minus 2. Now when it will be n minus 4, you will get here plus 2, that is going to your n minus 2, okay, because n minus 4 plus 2 is going to your n minus 1, okay. Now again you substitute this, open this with the recurrence t of n minus 3, it's n minus 3 plus 1, n minus 3 plus n minus 4 plus 2. Now it is going to be n minus 2, n minus 2, n minus 2 will get cancelled, so you will get in the next n plus 1 by n minus 3. See, n plus 1 by n minus, so this I have written, whatever you got, n plus 1 by n minus 2, n minus 2 by n minus 3, then t of n minus 4 plus 2, and rest I have written as it is, so this will get cancelled out, so we'll get n plus 1 by n minus 3 t of n minus 4, and 2 with this, whole, 2 with n plus 1 by n minus 3, and this I have written as it is, 2 n plus 1 by 1 by n plus 1 by n minus 1 plus 2. Now you take 2 n plus 1 and 2 n plus 1 as common in between these two, so 2n plus 1 by n, 1 plus n by n minus 1. Similarly it will go till n minus 2 plus 2. So it will keep on going like this. So if it is having n minus 4, then plus 2. See, it is going plus 2. Till plus 2 it will go, n minus n, n minus n minus plus 2. So if it is having here n minus 3, then here n minus 4. So here if it is having 2 here, then here it will have 1 greater, okay. So if it is having here, it's going till 1. So if it is 1, then it will be 0. So t of 0 is 0 only. So if it is 0 here, then it will go till 1 by 2. So here it is having 1 by 3 also, 1 by 4 also, like this, okay. So this term you are getting 0. Now this term 2 you are getting 2n by 1, 1 by n, 1 by n minus 1, 1 by n minus 3 till 1 by 2, and 1 plus 1 by 2, 1 by 3 is a harmonic series which is equal to log n. So in log n, if you just subtract minus, you will get this, so that I have written here. That's we are getting 2n log n minus plus 2n minus 1 minus 2n plus 1 is 0 minus n log. Please let me know whether it is clear or not. So I have tried my best to explain this recurrence. Please let me know whether it is clear or not. So I have put my all my effort to make it clear. Please let me know whether it is clear or not. I have taken every steps to explain. So randomized time complexity is going to your n log. So randomized time complexity is going to your n log. So when I have seen this, then at that time even I get means get in first go it's look very dangerous. But after that, when you will go step by step, then it will get clear, and you will get means I enjoyed when I have studied this, okay, because it is one of a very, if you do some tough things now, you will like it. So hence you can write, hence expected number of, hence, so here also you are getting expected number of comparison as n log, but worst case will be big of n square only. Here also worst case is going to be big of n square, because if I give you the input like equal number 2 2 2 2 2 2, so here if you will check any number as the random index, Again partition, again always partition will be like this, will be like this. Okay, so that increasing order and decreasing order, that problem will get reduced. Method I go in detail so that everyone can understand the things. Okay, so hence expected time, expected number of comparisons, hence expected number of comparison, hence expected number of comparisons required by by randomized quick sort is big of n log n. So it's going to be n log n only, but the worst case, is going to your, but the worst case time complexity is going to your big of n. Worst case is going to your n square only, but only when the input is same, then only you are going to get worst case. Okay. So in case of increasing and decreasing order, you are not going to get worst case. Means only in very rare cases now you're, because in practice, in practical we have seen that most of the time randomized quicksort is getting in log most of the time. But worst case time complexity is time complexity of randomized randomized quicksort is randomized quicksort is big of n square, is big of n square. Okay, so now some notes you write. Now as a note you can write, so these are the experiment value. Okay, the running time of the randomized quicksort, the running time. See, this question is very important in your interview. So when you are going for interview, you please prepare this thing. Okay, in interview they will ask you to solve this. Okay, because in gate exam, there the proof are not going to be useful, because there they are not going to ask you to prove anything. But in your gate exam, means in the interview, the proof will be important. So running time, the running time of quicksort, the running time of quicksort. So in this case, the running time of quicksort does not depends on the input. So the running time of quicksort here does not depends upon the input. The running time of quicksort does not depend does not depend on the input. Does not depend on the input. It does not depend on the input. It depends on the random number. It depends on the random number. It depends on the random number. It depends on the random number provided by the provided by the generator, that is the random function provided by the generator. So the running time of quicksort does not depends upon the input. It does not depend upon the input. It's depend upon the random function, that is called here generator. Okay, that is called here generator. So these are the experiment value. Thus for the same input, thus for the same input, the program, thus for the same input, the program might the program might take 3 sec 3 sec today. The program might take 3 sec today and 5 sec tomorrow. Means if it is taking 3 seconds today, then 5 seconds tomorrow it will take, because it is not depends upon the value of the array. It depends upon the random number that you are checking. Okay, so the random number that you are getting. So the average time taken, the average time taken over many different over many different runs of the program of the program would give us the expected time, give us the expected. So you have to run the many programs, then you are going to get the expected time. That's the average time. Okay, so you have to run the average time taken over many different run of the program would give us the expected time. Okay, so you have to run this program for many number of times. So these things you will get in research also. Okay, but in IITs, BTech student are learning this thing. Okay, in IITs, this randomized quicksort is taught in their BTech syllabus. and we are learning in when we are preparing for gate. So in our colleges they will never teach. Same as saying that, we are taking average. Taking we are taking average. We're taking average over all possible random number, over all possible number random number sequence random number sequence provided by the provided by the generator. Okay, is it clear? So it is same as saying that we are taking average over all possible random number that we can get as a generator. So it is like we are taking the average of all the possible number generated by this. Okay. Hope it is clear to all of you. In any place, if you will face the difficulties, please ask me. So now randomized quicksort is finished. So here also the expected time is going to your n log n, but worst case is going to your n square. But where rare you are going to get the worst case. In practical, we are always getting the n log n only, which is going to be the best case of quicksort and even the average case. So that's why to improve the time complexity of an algorithm, we use randomization technique, and by using randomization here, so randomized quicksort is having a better performance in real time. Am I clear to all of you? In any place if you are having doubt, please let me know.